We'll start in 1 minute. Were the buses running late today? Were the buses running late today?
No, I was just running late.
Today we'll be in Chapter 7, Section 6 on solving rational inequalities. Solve each rational inequality and write the solutions in interval notation. In general, when solving a rational inequality, we want one side to be 0, which we already have. Then we want to find all of the x values that make the numerator 0 combined with the x values that make the denominator 0. Those numbers are the endpoints of the intervals. And once we know the endpoints of the intervals, we'll be able to test the intervals to determine what the solutions are for the inequality. So the numerator is just x plus 2. So I'll refer to those numbers as endpoints, the numbers that make the numerator 0 combined with the numbers that make the denominator 0. X equals negative 2 makes the numerator 0, and x equals positive 3 makes the denominator 0. So those two numbers on the number line divide the number line into 3 separate intervals. I'll label those intervals using Roman numerals 1, 2, and 3. The first interval is from negative infinity to negative 2. The second interval, or the middle one, is from negative 2 to 3. And then the third interval is from 3 to positive infinity. What we're going to do is we're going to pick a test point from each of the 3 intervals. And with each of the test points, we'll replace x in the inequality with the test point and determine if the resulting equation or inequality is true or false. If we get an inequality that's true, that means every number in that interval from which the test point came is part of the solution set. And as you would expect, if we get a false inequality, the interval from which the test point came is not part of the solution set. Okay, so I'll just make note of what we're doing here. We're going to pick test points. In the first interval on the left, we can pick any number that we want that's less than 2. There are infinitely many to choose from. We just want to pick one. So from the first interval, I'll pick x to be negative 3. In the second interval, between negative 2 and 3, usually picking 0 is a handy choice. And then in the third interval, I'll pick x to be 4. Okay, then over here, we'll use those test points in the inequality. So in this inequality, x plus 2 over x minus 3 greater than or equal to 0, we're going to replace x with negative 3. So in the numerator, negative 3 plus 2. In the denominator, negative 3 minus 3. Then do the arithmetic. Negative 3 plus 2 is negative 1 in the numerator. Negative 3 minus 3 is negative 6 in the denominator. Simplify this. Negative 1 divided by negative 6 is positive 1/6. And then put in the inequality. The inequality is greater than or equal to 0. This inequality is true. 1/6 greater than or equal to 0 is true. So that means every number in the interval from negative infinity to negative 2 is part of the solution set. Okay, now we'll move on to the second interval. For the second interval, our test point is 0. So in the inequality, replace x, each of the x's with 0. In the numerator, 0 plus 2. In the denominator, 0 minus 3. We simplify that. 2 divided by negative 3 is negative 2/3. And then we're using this inequality, greater than or equal to 0. And this inequality is false. Negative 2/3 greater than or equal to 0 is not true. So that means none of the numbers in the second interval are solutions. Then finally, in the third interval, our test point is 4. So in the inequality, replace each x with 4. Let's do a little bit of a shortcut. In the numerator, 4 plus 2 is 6. In the denominator, 4 minus 3 is 1. 6 over 1 greater than or equal to 0 is true. So that means all of the numbers in that third interval from 3 to infinity are solutions. Then we have to determine if the endpoints themselves, negative 2 and 3, are part of the solutions. So with a little practice, you'll know what to do just by looking. But if it's not obvious, you can always test the endpoints. So we'll go through that here. We'll test the endpoints in the inequality. One of the endpoints is negative 2. So replace every x in the inequality with negative 2. In the numerator, negative 2 plus 2 is 0. In the denominator, negative 2 minus 3 is negative 5. 0 divided by negative 5 is 0. And then the inequality, greater than or equal to 0. So is that true or false? It's true. It's the or equal to 0 that makes it true. Of course, 0 is not greater than 0, but this is 0 greater than or equal to 0. Since 0 is equal to 0, the or equal to 0 makes it true. So that means we're going to include that endpoint. Then test the other endpoint, x equals 3. Then replace every x in the inequality with 3. So in the numerator, 3 plus 2 is 5. In the denominator, 3 minus 3 is 0. So 5 divided by 0. So what do we make of that? So anybody online know what 5 divided by 0 is? Anybody in class know? You can't divide by 0. This is undefined. 5 divided by 0 is undefined. In the practical sense of dividing by 0, you'll find that it's just nonsense to try to divide by 0. So that means we exclude that endpoint because we get an undefined expression. Okay, graphing the solution set from negative infinity to negative 2, and we're including negative 2. So graphically, we put a bracket that opens to the left of negative 2, and then we shade in the number line to the left. The other interval, from 3 to infinity, we're excluding 3. So instead of a bracket, we put a parenthesis to indicate that 3 is excluded. Then the interval notation for this, this part of the number line, x is less than or equal to negative 2. Whoops. This is not interval notation yet. This is the algebraic notation. We might as well review algebraic notation while we're at it. Okay, so x is less than or equal to negative 2, or x is greater than 3. This is the algebraic notation. And then the interval notation, we write parenthesis negative infinity, comma, negative 2, bracket, then the union symbol, and then parenthesis 3, comma, infinity. So this is the interval notation. Okay, one thing to remember about rational inequalities, an x value that makes the denominator 0 is never, ever part of the solution set. The x value that makes the numerator 0 may or may not be part of the solution set. It determines on what kind of inequality we have. Since this one is greater than or equal to 0, we do include the endpoint that comes from the numerator. Okay, let's move on to the second one. The second one is similar to the one we just did, but different. When solving rational inequalities, we want one side to be 0. We already have that. Then we want to find the endpoints of the intervals, the numbers that divide the number line into separate intervals. So once one side is 0, the endpoints are the x values that make the numerator 0 combined with the x values that make the denominator 0. So we have two endpoints, negative 5, that makes the numerator 0, and negative 2 makes the denominator 0. On the number line, those two numbers divide the number line into 3 separate intervals. Negative 5 is to the left of negative 2. So we have 3 separate intervals to test. Then we pick test points. In the first interval on the left, pick any number you want that's less than -5. So I'll pick x to be -6. In the middle interval, pick any number you want between -5 and -2. So I'll pick -3. And then in the third interval, pick any number you want that's greater than -2. I'll just pick 0. Okay, then in the inequality, replace every x with our test point. So from the first interval, we're picking -6 for x. In the numerator, -6 plus 5 is -1. In the denominator, -6 plus 2 is -4. We'll simplify this. -1 divided by -4 is +1/4. The inequality is less than 0. 1/4 less than 0 is false. So that means none of the numbers from -infinity to -5 are solutions. In the second interval, the test point is -3. So in the inequality, replace every x with -3. In the numerator, -3 plus 5 is +2. In the denominator, -3 plus 2 is -1. 2 divided by -1 is -2. Then the inequality is less than 0. -2 less than 0 is true. So all of the numbers between -5 and -2 are solutions. In the third interval, our test point is 0. Replace every x with 0. In the numerator, 0 plus 5 is 5. In the denominator, 0 plus 2 is 2. And +5/2 less than 0 is false. So none of the numbers in the third interval are solutions. Okay, I'll point out something that might probably seem obvious, but still something that you need to remember. When you're using the test points, we always use the same inequality, less than 0, less than 0, less than 0. Okay, what about the endpoints? Do we include or exclude the endpoints? You can remember that with rational inequalities, endpoints that come from the denominator are always excluded. So -2 is excluded no matter what the inequality is. Hey, if you're ever in doubt, you can always test the endpoints. So we'll go through the trouble here. Test the endpoints. One of the endpoints is -5. So we're testing -5. Replace every x with -5. In the numerator, -5 plus 5 is 0. In the denominator, -5 plus 2 is -3. 0 divided by -3 is 0, but the inequality is less than 0. 0 less than 0 is false. No number is less than itself, so we're excluding -5. Then the other endpoint, -2, In the numerator, negative 2 plus 5 is 3. In the denominator, negative 2 plus 2 is 0. Division by 0 is undefined. So this means neither endpoint is included. Graphically, we put a parenthesis at negative 5 and a parenthesis at negative 2, and then we shade in the interval in between. Let's write both the algebraic notation and interval notation for the solution. The variable is x. X is between negative 5 and negative 2. So the algebraic notation is negative 5 is less than x, which is less than negative 2. The interval notation, parenthesis, negative 5, comma, negative 2, parenthesis. Okay, now we're ready to go on to the next level. So this one, we have x minus 4 divided by x to the second plus 3x plus 2 is less than or equal to 0. First, find the endpoints of the intervals. The endpoints of the intervals are the x values that make the numerator 0 combined with the x values that make the denominator 0. The x value that makes the numerator 0 is 4. That one's pretty easy to find. It's not too hard to find the x values that make the denominator 0. We can just factor the denominator. So let's just rewrite this inequality with the denominator factored. The denominator in factored form is x plus 2 times x plus 1. So we can identify the endpoints now. All right, so tell me what the endpoints are. The endpoints of the intervals that we're going to test. A hint is there are 3 endpoints. The x value that makes the numerator 0 is 4. Okay, I got some answers online, and they look correct. X equals 4. That makes the numerator 0. X equals negative 2. That makes this factor 0. I'll just write x equals 4, negative 2, and then negative 1 makes the other one 0. Okay, so we use those numbers to divide the number line into 4 separate intervals. Negative 2 is to the left of negative 1, which is to the left of 4. So this time we have 4 intervals to test. Okay, in the interval on the left, I'll pick -3 as the endpoint. And then in the inequality, replace every x with -3. You can use the factored form of the denominator, or you can use the original denominator, x squared plus 3x plus 2. It shouldn't matter. I'll go ahead and use the factored form. Replace every x with -3. In the numerator, -3 minus 4 is -7. In the denominator, we have 2 factors. -3 plus 2 is -1. The other factor, -3 plus 4, is -2. So we get -7 divided by +2, or -7/2. The inequality is less than or equal to 0. And that is true. So all of the numbers from -infinity up to -2 are solutions. In the second interval, well, we'll have to pick a test point that's a fraction. So I'll pick x to be -3/2. And then in the numerator, -3/2 minus 4 is -5.5, or -11/2 in the numerator. In the denominator, one of the factors is x plus 2. -3/2 plus 2 is +1/2. And then the other factor, x plus 1, -3/2 plus 1 is -1/2. So this number is going to be positive. It just turns out to be positive 22. And 22 less than or equal to 0 is false. Okay, so none of the numbers between -2 and -1 are solutions. In the third interval, pick a number between -1 and 4. 0 is in that interval, so I'll pick 0 as the test point. When picking 0, I'm going to use the original inequality that doesn't have a factor denominator. Replace every x with 0, so the numerator, 0 minus 4 is -4. In the denominator, 0 squared plus 3 times 0 plus 2 is 2. -4 divided by 2 is -2. The inequality is less than or equal to 0, which is a true inequality. So all of the numbers between -1 and 4 are solutions. And finally, in the fourth interval, pick any number you want that's greater than 4. So let's pick 5. And I'll go back to the factor denominator. In the numerator, 5 minus 4 is 1. In the denominator, 5 plus 2 is 7, multiplied by 5 plus 1 is 6. So we get a positive 1/42. The inequality is less than or equal to 0, and this is false. So none of the numbers from 4 to infinity are solutions. And what about the endpoints? Remember, the endpoints that come from the denominator are never included. So we know right from the start, that we exclude -2 and -1. And the numerator, the x value that comes from the numerator, will be included if the inequality has an or equal to part. So we include 4. Okay, so graphically, from -infinity up to -2, but we're excluding -2. So parenthesis that opens to the left at -2. So this represents -infinity up to -2, but excluding -2. Then the interval from -1 to 4, we're excluding -1. And we're including 4. So we put a bracket at 4, and then we shade in the interval between -1 and 4. Okay, the interval notation, this part of the number line on the left, this is parenthesis -infinity, comma, -2 parenthesis. Then we use the union symbol, and then this setup here from -1 to 4, where we exclude -1 and include 4. This is parenthesis -1, 4, bracket. That is the interval notation. We might as well write the algebraic notation. You'll need to know that on the final, probably even before that, maybe, but at least on the final. So let's review the algebraic notation. This part of the number line on the left, x is the variable, so that part is x is less than -2. And then we have another disjointed interval, so we use the word or. In the interval notation, the union symbol is what is translated from or. And then this set of numbers, -1 to 4, excluding -1 and including 4, we write -1 is less than x, which is less than or equal to 4. Well, if I haven't put you to sleep yet, I'll give you a couple of minutes to work on number 4. And you can probably type in the answer if you're watching online. At least enough that I could get the gist of it. So work on that for a couple of minutes and see what you come up with. What are the endpoints? Let's start with x values that make the numerator 0. Well, the numerator doesn't have x in it, so we don't get any endpoints from the numerator. We just have a constant in the numerator. What about the denominator? Yeah, so -7 and 7. If we factor x squared minus 49, this is a difference of two squares. One factor is x minus 7, the other one is x plus 7. So the x values that make the denominator 0 are +7 and -7. So divide the number line into 3 separate intervals. The endpoints are -7 and 7. Okay, then we'll pick test points in the first interval on the left. Pick any number you want. I'll pick x to be -8. And then in the inequality, we have 7 divided by the number -8 squared is 64 and minus 49. So we get +7/15 and then greater than or equal to 0. That is true. So all the numbers from -infinity to -7 are solutions. In the second interval, pick any number you want between -7 and 7. Since 0 is in that interval, that's a convenient number to pick. So in the inequality, replace x with 0. And we get 7 divided by -49, or -1/7. But -1/7 greater than or equal to 0 is false. So none of the numbers in the middle interval are solutions. In the third interval, pick a number greater than 7. I'll pick 8. And then in the inequality, 7 divided by 8 to the second is 64 minus 49. So we get 7/15, again, greater than or equal to 0, which is true. So all of the numbers between 7 and +infinity are solutions. We're going to exclude the endpoints. Those are the numbers that make the denominator 0. So exclude -7 and 7 from the solution set. So graphically, we put a parenthesis at -7 opening to the left, and then shade everything to the left. And then a parenthesis opening to the right at +7, and then shade everything to the right of that. The interval notation, parenthesis, -infinity, comma, -7, parenthesis, and then union symbol, parenthesis, 7, comma, infinity. This is the interval notation. The algebraic notation, x is the variable, so this part of the number line, x is less than -7. And then or x is greater than +7. On the next page, we'll jump to number 6. I'll just make a comment about number 5 first. So factoring the numerator is pretty easy. I'll go ahead and write the factors. One factor is x plus 5, and the other one is x minus 2, and the denominator x plus 2. And so the endpoints, are x equals negative 5, x equals 2, and then from the denominator, x equals negative 2. And then you can go about picking test points the same way that we did on the previous examples. But number 6, this time we don't start out with 0 on one side. So we have some preliminary work to do. We start by subtracting 1 from both sides. And then we want to write the left-hand side as a single rational expression. So we need a common denominator. So we multiply minus 1, you can think of that as minus 1 over 1, by 1 in the form x minus 5 divided by x minus 5. And then be careful with the arithmetic. So if we have the common denominator x minus 5, then we have 2x minus this entire numerator. So we have to subtract the entire quantity x minus 5. So we get 2x minus x, which is just x. And we're also subtracting negative 5, which is equivalent to adding 5. Okay, so this is now in the form that we want it. One side is 0, and we can easily see what the endpoints are. The endpoints are the x values that make the numerator 0 combined with the x values that make the denominator 0. So the two endpoints are x equals negative 5 and x equals 5. So that didn't turn out too bad. So if it helps, you can plot the endpoints on the number line and then identify the separate intervals. We have 3 separate intervals. So we're going to solve the inequality by picking test points. Okay, after we pick a test point, we can use any of the inequalities. It seems to me that the simplified result where we have 0 on one side, this in my opinion is the easiest inequality to use. But if you want to use the original inequality, you can if you want. You just have to make sure that you do pick a test point from each of the 3 subintervals. So in the interval on the left, let's pick x to be negative 6. And then in this inequality, replace x with negative 6. In the numerator, negative 6 plus 5 is negative 1. In the denominator, negative 6 minus 5 is negative 11. Negative 1 divided by negative 11 is positive 1/11th. And then the inequality is less than or equal to 0. And that is false. So none of the numbers from negative infinity to negative 5 are solutions. Okay, in the middle interval between negative 5 and 5, we can pick x to be 0. And then in the inequality, 0 plus 5 is 5 in the numerator. 0 minus 5 is negative 5 in the denominator. 5 divided by negative 5 is negative 1, and negative 1 less than or equal to 0 is true. So the numbers between negative 5 and 5 are solutions. And then in the third interval, pick a number greater than 5. So we can pick 6. In the inequality, 6 plus 5 is 11 in the numerator, and 6 minus 5 is 1 in the denominator. 11 over 1 less than or equal to 0 is false. So none of the numbers greater than 5 are in the solution set. Okay, the endpoints, one endpoint will be included, and the other one will be excluded. So we include negative 5. That's the one that makes the numerator 0. Numerators are permitted to be 0, but denominators are not. So we exclude 5 because that's the number that makes the denominator 0. Okay, so graphically we have a bracket at negative 5 opening to the right, a parenthesis at positive 5 opening to the left, and then shade everything else in between. The interval notation, bracket negative 5 comma positive 5 parenthesis. This is the interval notation. And then algebraic notation, negative 5 is less than or equal to x, which is less than 5. This is the algebraic notation. Okay, we have less than 2 minutes left. I suppose until we run out of time, we can continue to work on this one. We found the endpoints already, negative 5, negative 2, and 2. So this one has 4 intervals to test. So one thing you can do if you're careful, if the linear factors that you get by factoring the numerator and the denominator, if they're all different, like they are in this case, then the intervals are going to alternate either yes, no, or no, yes, no, yes. But that's only if the linear factors are different. So if we pick 0 as one of our test points, that's in the third interval, and then replace every x with 0, in the unfactored form, that's probably the easiest. we get negative 10 divided by 2, which is negative 5. The inequality greater than 0 is false. So that means none of those numbers are solutions. So if all of those linear factors are different, then the intervals alternate. So this will be no, yes, no, yes. Yeah, that's all we have time for today. Tomorrow will be in the next section.